Okay. Last part to this lesson is this part called the discriminant. Alright, now, we talked about it yesterday. We learned yesterday that it's the b squared minus 4ac part to your quadratic formula, right? Okay? It's the number that's underneath that square root, okay? And we learn how to use it, plug it in, simplify from there, okay? We know all that stuff. What we need to learn today is this. Your discriminant tells you so much, okay? It tells you things about your answer. It tells you things about your quadratic equation. Mainly, it tells you how many and what type of solutions you're going to have, okay? So on your homework tonight, you're going to have to look at that discriminant number, use that number, and classify it one of 3 different ways, okay? So, as far as you're concerned, let's put it up here, b squared minus 4ac can be greater than 0, b squared minus 4ac can be equal to 0, b squared minus 4ac can be less than 0, right? Those are the 3 ways a number can be. Essentially, positive, negative, 0. Okay? Each one of those 3 classifications is going to give you a different number and different type of solution set. Okay? For example, I want you guys to flip back through your notes. Okay? I want you to find the last problem we did yesterday. Okay? The last problem we did yesterday had a discriminant of what?
94.
Not 92, one after that. We did one after. Negative 4. Okay? Negative 4. So it was less than 0, right? So we're talking about this guy down here. Now, when you had an answer of negative 4, your solutions were what? Anybody remember? No? Or here, maybe not what they were, but what did they have in them? The I. There you go. Okay. Had the I in it, right? Do you remember how many of them we had? Think about the middle sign. That middle sign would have been plus or minus, which means we actually had 2. That's going to be the case every single time your discriminant number is less than 0 or negative. You're going to have 2 imaginary or complex solutions. Okay. You're going to have 2 imaginary or complex solutions every single time. You don't have to write imaginary or complex. You can write one or the other. So you can either say 2 imaginary solutions or 2 complex solutions. Okay? Either one's the same thing. All right? Okay, now I want you to go back through. There was a discriminant that we had. There's a bunch of them that we had when they were greater than 0, right? I think one was like 121, 144, and then 92, correct? I think those were our 3 that were bigger than 0. Positive, right? Okay. What type of solution? How many? Let's do it this first. How many solutions did we have in those cases? Did we have 1, 2, none, 4, 3? For the ones like 121, okay, or 144. We had 2, right? Okay, we had 2. That's going to be the case all the time also. Okay, so we have 2. Those we don't call imaginary because they're not. What are those types of numbers? Real. Good. So 2. Two real solutions. Okay. The last type we got, this one, on the top one, you're going to have 2 reals, which mean, you good? Okay. What about when that one that we had equals 0? I don't remember what that answer was. When it equaled 0. We had like no work for it.
Oh, it was just comparable.
Right, which was, the answer was, anybody remember? Discriminant was 0. That answer was? No.
It was. Oh, it was. Wasn't it the? It was just like. That's all you could do. So you didn't fix the problem that you usually do. It didn't equal 0. So
But there was one that did equal 0. Right? And we had a solution for it. Yeah, but with 0, whenever we had to equal 0, oh, I'm trying to think of one here. Hold on, let me think of one. Program 0. What would it have been? It'd have been. Got your program? Ready to go? Ready to rock and roll? 1, 8, 16 is what it was. That was the question. X squared plus 8x plus 16. Okay, so 1, 8, and 16. Okay, Cody? -4, -4. Now is -4 the same number? Yes, so we didn't have 2. We had how many? 1. There we go. So we have 1. Is that a real number or an imaginary number? Whoa. It's real. Negatives are real too, right? Okay. That's the solution, right? Not the discriminant itself. The solution. So we had 1. Sorry. Real. Solution. Okay. So on your homework tonight, we're going to basically take what this stuff is. We're going to do some of these real quick, okay? We're going to take some of these and we're going to do them. We're going to do 4 today. We're going to take what we did yesterday, combine it with this. All right? Burke?
What about the one that equaled, it was like -3 plus or minus 1, square root 23?
That falls in the real part, in the top, up here.
Oh, so
That falls under here, yeah. I threw them all, whether it's a perfect square or not a perfect square, those all fall up here. Okay? Okay, so I'm going to change the directions just a little bit. Find the value of the discriminant for each equation. Describe the number and types of roots, and then we're going to add on, because that's how your homework's going to be. Then state the solutions. Okay. So first one, 7x squared. Let's number these so you guys know what I'm talking about. 1, 2, 3, and 4. There we go. Okay, so the first one, 7x squared minus 11x plus 5. Just tell me, let's first get A, B, and C. Okay. What's A in this case? What's B? What's C? 5. Good. 7, -11, and 5. So you run it through your program. Okay, quad form. 7, enter. -11, enter. 5, enter. Okay. Now it tells you discriminant's what? -19. Okay. Now, from your earlier notes, when it's negative, what does that tell you about your solutions? You have how many? 2, and they are complex. Good. So part A, let me get this. Let's get rid of this here now. So A, state the discriminant. -19. B, state the number and type of solutions. 2 complex. And then C, what are those solutions? So this one we got to go a little further, right? Okay, so we got to go -B, which was 11, plus or minus square root Negative 19, because since that's your discriminant, right? All over 2 times 7. So 11 plus or minus I square root 19 all over 14. On number 2, x squared plus 22x plus 121. Alright, first up, what is your discriminant? The actual value. Or here, what's A? What's B? 22, what's C? 121. Good. 122 and 121. Run those three, what's your discriminant? 0. Good. So your discriminant value is 0, which tells you what? You're going to have one real. Good. And then then state the solution. So this one, what is the solution? Negative 11. See how nice that is? That makes sense. Alright, number 3, what's A? Negative 5, what's B? What's C? Negative 1. So negative 5, sorry. 8, negative 1. What's your discriminant? 44, which means you're going to have 2 real solutions. Alright, and then when you hit enter, those solutions are decimal numbers, right? So we got to clean that up now. Alright, so we put 44 in for the square root. Negative b would be negative 8 all over 2a, which would be negative 10. This one's a little nasty. You get negative 8 plus or minus 2 at 11 over negative 10, and then you got to reduce that. So this isn't a great example because it's kind of crushed, but okay, just kind of go with this for tonight, okay? So then divide everything by negative 2. Do negative 2. No, it's just 44. So you get 4 plus or minus square root of 11 all over 5. Okay. If that one didn't fully make sense, that's okay. Be careful, alright? Okay, last one, number 4. What's A? What's A? You sure?
I mean, 15.
Khalifa? 15. Why 15, sir?
Oh,
Because of the exponent. There you go, okay? Because it's the one attached to x squared. Ax squared plus bx plus c. They're trying to trick ya. They're trying to be tricky, run DMC types. Okay? Be careful with that. A is 15. B is negative 7. And C is negative 4. Alright, be careful with that. Alright, so then part A, what's your discriminant here? 289. Which means you're going to have 2 real solutions. Complex is if it's negative. Okay, if your discriminant's negative, it's complex. If it's positive, it'll be real. And then C, what are those solutions? And? Good. 4/5, negative 1/3. That's what you had, Jaron, right? 4/5, negative 1/3. Good. Your homework. Yeah, we did. The
discriminant 0?
yeah, second one or the third one, one of the two. Yep. Page 205, 21 through 29.